Okay, I think we can get started. Welcome back, Data Track. Oh, I'm a poet and didn't know it. I'm Jennifer Kofoid again. I'm a senior engineer with the Department of Water Resources, and I work on the water plan. So I didn't introduce myself earlier. I thought I should introduce myself now. I'm going to introduce our land use folks. And we have Curtis Anderson from DWR, who's going to present kind of an introduction and overview of the transition that we've undertaken to remote sensing with land use in the department. And Joel Kimmelshoe is here from Land IQ, the company we contracted with, the group that we contracted with to do the remote sensing. And he's going to talk a little bit about the procedures and methodology for the remote sensing and why it's going to present a fabulous land use visualization tool that's been developed. It's a great way to look at the land use data. So without further ado, here's Curtis.
All right. Well, thank you for joining us. And this is a project that I'm super excited about. If you work for a state agency or any type of agency or large organization, you may realize or may have noticed that change doesn't happen very quickly. And this change has been a long time coming, but it's a monumental change, I guess, in my 26-year career here at DWR. Our ability to quickly evaluate land use and also do it for the whole state. So I'm going to give an overview from DWR's perspective, as Jennifer said. And so why does DWR collect land use? So we work with other agencies and the public to, we're kind of like, as you've heard about, the water plan is kind of the focus of this, but developing strategic goals and actions to conserve or manage or develop and to sustain California's water resources. In 1947, the California legislature requested an investigation for what is the present water use and what is going to be the future water needs for California. So it's kind of the era of development. We need more supplies. California is growing. The economy is booming after World War II, and we need to get a better handle on where we're going as a state when it comes to water use, water needs, water management. And in 1954, DWR began a formal program of determining agricultural water use and urban water use, and started putting that in the California water plan, which you're all here to talk about. And this is updated every 5 years. So by the mid-1960s, all of California, to some extent, had been classified both urban and agricultural, and that practice continues to this day. The current program manager for the Department of Water Resources for the land use side of things is Simon Etching. And so how does DWR collect land use? Originally, we started with, like, if anybody's seen the old USDA 9x9 air photos, black and white air photos, and we would go through and we'd actually draw on those and classify crop types, land use on those photos. And then we started contracting out, and we would hire companies to actually fly airplanes and take pictures with 35mm slides, and we could get a little bit better resolution on crops. And we would overlay, we would analyze what we thought those crops were, put them on quad maps, go out in the field and verify that. And then in 1992, we started using GIS, and that technology has just increased and increased to what you'll see a demo on before, but the ability to bring quads into a format that you could work on, you could determine areas very quickly. So back when we were doing it on quad maps, we used to actually draw on hard copy quad maps the land use. So say we wanted mapping almonds. we would draw all the almond orchards on all the quad maps, and we'd actually cut out all the different land use, so almonds, walnuts, field crops, and we would weigh the paper from the quad maps on a chemical balance, and that's how we would determine the area of the kind of collected amount of crops within that quad or DAU or something like that. So you can see that once we started being able to do this in GIS, we were able to turn this around much more quickly and more accurately. If any of you have used a planimeter before, we used to use those too. So all of these methods still require extensive field work. So we had land and water use scientists go out in the field and actually eyes on the ground on the field identifying what it was. If we didn't put eyes on the ground, we couldn't really 100% tell what it was, especially when you go back to those old 9x9 air photos or something like that. So because of this need to see all the crops, in person, there's 4 regional offices in the state of California, and each of those regional offices can do about between 2 and 6 counties per year of land use. So the way we were doing it is we would do a whole county and do all the land use of that county, and we try to do 1, 2, 3, or 4 of those per year, depending on the funding, the staff availability, how big the county was, how much land use there was in there. So that equated to every year the Department of Water Resources was accurately determining land use in between 4 and 12 counties per year. And then between these surveys in the counties that we didn't actually do a complete survey on, we would true them up with Ag Commissioner reports to figure out what the crops are doing in between. Because like some of the counties in the Central Valley we may do every 3 to 5 years, but some of the outlying counties we may do every 10 years or something. So we rely on the Ag Commissioner reports. So what are the issues with doing this infrequently? The Ag Commissioner reports, if you've ever seen those, they're not spatial. They don't have a map that show where walnuts is. It's like a county type tabulation of total number of walnuts, total number of almonds and crops. And so what we do is we kind of apply those changes on our last land use survey, but you can imagine that there's drift as it gets to be 5 to 10 years since we've done an analysis. There's a lot of drift and inaccuracy on a field-by-field basis what's being grown. And then when you start compounding that and trying to do aggregations on a DAU or a designated, what's DAU? Detailed analysis unit, or a county or a watershed, the inaccuracies get multiplied even more. So here's an example of what I'm talking about. So say that in 1991, these blue counties are the counties that the 4 regional offices were able to do complete land use surveys on. And then in 1992, we did those counties there. In 93, we did those counties there. In 94, we did those counties there. So you can see there's still a lot of counties that we would have to do accurate, complete land use on, and it may be quite a time before we go back and redo this survey. And there's a lot of changes, especially if we're looking at like a major drought during that time, or other issues or other cultural practices, agricultural practices. So it's just a demonstration that there can be a lot of drift of the data that we're trying to deal with. And so during this last drought, on March 12, 2015, LA Times op-ed Jay Famietti, he came out and said California only has 1 year of storage left. It was reported as water. So California has 1 year of water left. So DWR's director said, is that true? And so it was easy to determine how much surface water we could deliver. You just add up all the reservoir storage at that time and figure out, can we convey it to certain areas of California? Can we distribute that? But the big unknown was it's difficult to estimate the actual water use because we don't have up-to-date information and we don't have it on a statewide basis because of all these issues that I discussed before. So why did we switch to doing statewide land use? So in 2014, a SGMA program required a basin prioritization, and we needed to do an accurate assessment of groundwater use. So for the initial basin prioritization, DWR used the results from the CASGEM effort, and we used the data that I showed you earlier, the kind of every few years land use county by county. But DWR wanted to increase the accuracy and the repeatability of that. So we released our basin prioritization, and people came back and said, well, I don't think that groundwater use is correct. How did you get that? And we didn't have a really strong process for how, we went from a county survey that was done maybe 5 years ago to using the Ag Commissioner reports and following that through. And so we really wanted to, in the future, be able to have more defensible and easier to follow ways of managing the data and making decisions. And then internally, there's lots of programs that DWR uses. So the land use program I mentioned, but the California Water Plan, the Bay Delta program, Water Use Efficiency Program, drought planning, et cetera. There's a lot of other programs that use this information of land use. And then externally, many other agencies, public agencies, and private organizations also use land use too. So how are we acquiring statewide land use? So we had recent experience with contractors that were doing remote sensing type analysis for DWR, and the Governor's Office and the Resources Agency approved a 4-year BCP budget change proposal that would fund DWR to hire a consultant to do remote sensing to do statewide land use instead of this county by county basis. So in April 2016, we put out an RFQ, and LandIQ was the company that was selected as most qualified. And so we did task order 1, which was to do statewide land use for crop year 2014. And we picked 2014 because it was kind of right before or when SGMA was enacted, so we're kind of considering that a baseline pre-SGMA. Now we realize, it's in the middle of the drought and there's a bunch of issues, but we had to pick a year kind of as a baseline, and it just so happened that LandIQ had done a lot of the ground truthing in the Central Valley that enabled us to do this kind of baseline. So that's the first starting point. We just executed, I think Joel got in his hands today, task order 2, which is to do complete statewide land use for 2016. We're planning to do that for 2018, and basically it depends how far this funding goes that we're getting in this BCP. So some additional information. This is not every crop that's grown in California in 2014. There's a lot of areas that do multi-cropping, triple cropping, double cropping. This is like the major crop that was grown in the summer of 2014. Amazingly enough, this data is not 100% accurate. Joel will talk about it a little bit, but it is like 96.45% accurate. But when you multiply that times 10,000 acres, 10 million acres, there are going to be areas that we don't have exactly right. And especially for this 2014 data set, LandIQ concentrated in the Central Valley when they did their ground truthing on this. So the outlying areas, the coastal areas in Northern California, we did not have ground truthing, and so the remote sensing analysis wasn't able to determine it as accurately as we'd like. But that will improve with future efforts, and as we get more input from the locals that can provide us data. This is DWR's first release of land use, and we've learned a lot through it. We're documenting what's working well, what's not working well, and what we would like to change in the future. We really believe that we should be providing the most accurate, comprehensive, and useful water data that we can for the citizens of California, for whatever those purposes are. And we welcome your comments and suggestions as we continue to move forward in this. So with that, we'll switch to Joel, and he'll talk about their process that they used.
Well, thank you, Curtis. Again, my name is Joel Kimmelshoe, and I'm with a firm here in town in Sacramento, another office in LA called Land IQ, and we specialize in land use analyses. And I'll just kind of jump into it. As Curtis mentioned, we were contracted in earlier in 2016 to kind of take a leap forward with regards to evaluating land use statewide. I think the key component here is that last word, that's statewide, all at once. So any of you that do modeling and things like that, it's nice to have a comprehensive land base that is consistent across the entire landscape that you're looking at. We've developed this method over the last probably about 10 years through some internal research and development work that we do, and looked at various approaches over those 10 years. And in a rough sense, and we'll start with kind of the higher level classifications, the statewide land use mapping is separated into three main categories: ag, managed wetlands, and urban areas. I'll get into some statistics a little bit later, but to just give you an idea, we mapped over 14 million acres of those three categories in much more granular detail. The results are 96.6% accurate crop maps and statistics that can be used for overall land use change and analysis, modeling, planning. You know, it's always a nice thing to have that type of consistent land use across a landscape, like I mentioned. Our approach is centered on, continually updating what we call field boundaries. So we put a boundary around every single irrigated field in the state of California down to 2 acres. And that is, the boundary encompasses only the homogeneous crop type. So think of a 40-acre block of land that may have a farm shop on one corner of it. It's not a 40-acre polygon, it's a 36.7-acre polygon that is just the homogeneous crop type. Or another way to think of it is the irrigated area of that polygon. We also have to achieve greater than 95% accuracy, and one of the other ways that we do that is we have very comprehensive ground truthing efforts that amount to somewhere between 10 and now 15% of irrigated ground. So we have a crew of people that during different times of the year go out and drive across the landscape and are logging fields as they drive on public roads for the purposes of establishing a data set that we use for both training our algorithms in the remote sensing side of things and also for validation of the ultimate results. From a validation standpoint, it's kind of like this. We drive by a number, let's say we drive by, 8,000 almond orchards. After a while, you can develop what we call a fingerprint or a signature of that almond orchard from all those data. We take some of those data and we put them aside like we never drove by them, and we forget that we ever had them. And then we classify them according to our algorithms that were informed by the other side of the data that we do recognize that we had. And then we come back and we say, we do actually have those ground truthing data. How well did we do? So we compare what we saw on the ground to what we predict in our classification. That's how we get the overall statewide accuracy of 96.6%. We use multiple image resources, whatever we can get our hands on, including NAPE, Landsat, RapidEye, Sentinel SAR, and a number of other spatial data resources. Our firm is made up of two kind of technical disciplines, land-based scientists and what we call spatial scientists, and we inform one another. Our land-based scientists, a lot of us are soil scientists, agronomists, crop specialists, land-based scientists with native and agricultural systems. And we inform our spatial scientists, GIS folks, remote sensing folks, as to what an almond orchard, for example, looks like, or a walnut orchard, and the crop phenological growth cycles, and all these, what we like to call lines of evidence that inform our approach that results in the statewide crop map. We do also, after the remotely sensed approach, look at photo interpretation and improvement of lower probability fields. And we use as many what we call lines of evidence, as I mentioned, as we can, including historic DWR mapping, county crop reports, crop data layers from USDA, and pesticide use reports, et cetera. So we're pulling together all sorts of different resources to result in as most accurate as a crop map as we can, or land use map. So here's some of the stats. We classified over 360,000 different polygons across the state. These are kind of unique stats that you can use at the dinner table if you'd like. And here in California, we have in 2014, we had about little over 9 million acres of irrigated ground. And from an urban perspective, we classified the outer boundary of all urban areas as well. So you have a land use. Think about it as land use layer and perspective, and I'll talk about that in a little bit. But that's half as much again, 4.5, 4.6 million acres. And then managed wetlands, again, is that third major category that I was talking about. That's close to 600,000 acres of refuges, both state, federal, private, duck clubs, a lot of other areas that, again, think about water use is a significant land use category in which water is used. So from an agricultural perspective, we include both irrigated and fallow fields, and fallow is a classification within agriculture. From managed wetlands perspective, it includes the irrigated and wetted area of a refuge, for example, and not the legal or boundary or the taxpayer boundary, if you will. It's actually only the land use of that which is actually wet. So there can be high and dry spots within refuges that never receive water. We're talking about consumptive use here. And then from an urban perspective, we classified only at the outer land use edge. So where urban ended, the backyard of a development ended, and some other land use began. Could be native, could be ag, could be a managed wetland or something else. So from agriculture again, our minimum field size was 2 acres. We have an overall accuracy of about 96.6% based on that independent ground truth validation data set that I described earlier. Our agricultural land use legend is over 45 different crop types, which make up about 98% of the irrigated ground in California. Now we say in California, you'll hear this from CDFA and others, and myself included, that we are bountiful producers of many different types of crops, sometimes over 300 to 400 different types of crops, and that's true. But the crops that we classified were grouped into these 45 different crop types, which makes up the vast majority of the irrigated ground. It's not that we didn't ignore the 2%. They're put into like miscellaneous truck crops or miscellaneous deciduous classifications, as I mentioned here. So there are miscellaneous classifications in grain and hay, field crops, truck crops, subtropical, deciduous, things like that. So I'm going to take you on a journey, I guess, from north to south in the state of California, and to try to give you, we're going to dive into the land use results. In DWR, as Curtis mentioned, has 4 regions, and we'll start in the northern region, which you see here. And many of you probably already know this, but it's kind of interesting statistics as well to summarize the work. The major crops in DWR's northern region include rice, of course, walnuts and almonds, alfalfa, and other tree crops a lot in the northern region. So the total irrigated and idle land classified in northern region was just a little under 1.5 million acres. So north central region, as we continue south down the state, you can see the counties that are represented here. Same legend applies, but the major crops are changed a little bit, not a whole lot, but somewhat. They include grapes and almonds and walnuts, as we saw in the north, but we also begin to get into more annual crops such as tomatoes and some fallow ground as well. That's about 1.6 million acres of classified ground in 2014. This is the big boy of them all, the south central region, the bulk of the San Joaquin Valley and over into the Salinas Valley as well. Major crops are quite diverse, but the prominent ones include grapes, almonds, pistachios, citrus comes into play here, and the ones that I've listed here. That's nearly 5 million acres of irrigated and fallow land in 2014. And finally, the southern region, not just a shade under 1 million acres, different cropping scheme altogether, and different environmental conditions altogether as well. But interestingly enough, we have a lot of different crops here, including subtropical, such as avocados, a lot of truck crops, coal crops, and other unique crops for Southern California. Again, that land area was just a shade under 1 million acres in 2014. So again, let's dive in a little deeper. This is the legend up in the upper left-hand corner, and you can see, maybe I may remember I mentioned earlier that we care a lot about field boundaries to achieve the accuracies that we get. And so we have created new field boundaries for everything. These are not recycled field boundaries. We use other lines of evidence, but they're all back-checked, so you can count on them to be very accurate with regards to the irrigated area of every field down to 2 acres. So if we zoom in a little bit more, I'll try to come around the corner here, but you'll see with my laser here that we do cut out farm shops and other corners that are not irrigated and areas that are not irrigated in the field. So again, this is the true irrigated area of the fields. And you can see some quite small fields and larger fields, and classified according to crop type. So now let's transition to managed wetlands and urban. As I mentioned before, the managed wetlands include federal, state, private, wildlife, and wetland areas, and we're classified in areas that we remotely sense as being wet or receiving water in some fashion or another. So again, a consumptive use component, a major consumptive use component with regards to land use in the state. And urban was classified by land use only as well, not city boundaries. That's not the boundaries they're used here. So you have to think of strictly on a land use basis. And I'll point out that the green is ag, and the pink is urban, and the brown in here is our managed wetlands. So you can begin to see a comprehensive carpet, if you will, across areas that we care about from the standpoint of consumptive use. Here's some interesting stats again. These are the results highlights in acres. Again, we talked about urban being about 4.5 million acres, managed wetlands a shade under 600,000, and ag about 9 million. But they can be classified into some of the categories, major categories that are listed here on the left and summarized in the smaller table, text table on the right. Again, the total classified ground was about 14.2 million acres. So people ask about how accurate are your results, and as Curtis mentioned, nothing is perfect. We want to be perfectly clear about that, but we do have a standard to meet that is equal to or exceeding 95% accuracy. So we have a standardized approach for determining that accuracy, as I described earlier. We set aside that portion of ground truthing results as an independent validation data set. We forget that we ever had them, and then we go back and compare them to what we did before. It evaluates omission and commission errors. So I like to use the analogy, we called it an almond orchard when it was really a peach orchard, or we called it a peach orchard when it was really an almond orchard. That's omission and commission. But in many cases, you should feel comfortable from a consumptive use standpoint that the confusion in that 3.4% error occurs in crops with very similar consumptive use. In other words, we're not mistaking almonds for carrots very often. And so that should give you some additional comfort within the data. And we calculate the accuracies for all crops that we have in our data set. And this is part of an accuracy matrix showing omission error. And again, our accuracies vary by crop due to sample size. So if we have our ground truthing effort only, let's say, acquired, 20 samples of chestnuts, for example, or pecans. There's a few pecans in the state. If you miss 2 of them, you're already at 90% accurate. But usually the overall accuracy is 96%, as I mentioned. In other crops, such as almonds, in larger acreage crops, our accuracies are much higher, in the order of 98+% accurate. So conclusions and upcoming efforts. As Curtis mentioned, we're already conducting the 2016 classification. It's interesting to take a look in our preliminary work on the 2016 classification, what has changed from 2014 to 2016. It's quite fascinating, actually. You know, people think that agriculture or land use doesn't change that much, but in fact it's quite dynamic. And we see a significant change in those field boundaries. About 10 to 15% of our field boundaries we're having to adjust. That may mean that a grower, split a field or joined two fields together, or just changed how they manage their land. We can continue to see a continued expansion of permanent crops, almonds, walnuts, pistachios, and other grapes and other permanent crops in the state. We continue to see urban expansion as compared to 2014. That's noticeable. And we also will update the urban and managed wetlands. We're beginning an effort right now here in the fall to conduct 2017 ground truthing work to begin to get a handle on more highly frequent rotational crops or multi-cropping systems, especially in the coastal areas where things are somewhat more dynamic than they are in other areas of the state. And that is those planning stages are going on now. And we also conducted 2017 ground truthing. So I'll end there, and I'll let Wyatt pick it up.
All right, let's transition. Thank you, Joel. Thank you, Curtis, for coming. We'll transition now to the app. And so the app is web-based. This was built with Esri's web app builder tool. For those of you out there who are interested in building similar tools, I really recommend you take a look at Esri's web app builder because you don't need much programming experience to put this together. So when you land on the app, first you'll get an application use disclaimer, just letting you know that whatever's represented in this web browser isn't necessarily accurate, and that doesn't even speak to the accuracy of the data. That just means the spatial accuracy itself, when it's reprojected in the browser, may not actually reflect boundaries as they are in reality. So let's see. Once you accept that, you're allowed in. And the first thing you'll see is statewide crop mapping. And so this is a tile cache of the entire data set. So it's not a raster. I mean, it's rendered as a raster, but you actually have the field polygons at your fingertips. So if you get into a smaller area, you can actually click on a field, and you don't click a raster point, much different. So when you click the field, you'll get the acreage, you'll get the standard legend, modified for remote sensing. So Joel mentioned 45 or so crop types that were remotely sensed. This is one of them, alfalfa and alfalfa mixtures, and that corresponds to the pasture category of the standard legend that DWR uses that has been modified for remote sensing. There were a few other modifications. I'll just point them out really quickly. So what does modified for remote sensing mean? One is this category, young perennial, didn't exist in the top level standard legend before. And so young perennial, that could be a vineyard, that could be a citrus, that could be a walnut, almond under deciduous. There's no real way to tell without visually confirming that to the satellite we call them image receptors. Right. And also idle. In the county land use surveys that DWR has done, you'll have the crop type followed by a fallow or idle designation. But in remote sensing, all you know is that it's idle. You don't know what it was before. So that has been also rolled up to the statewide standard legend modified for remote sensing. So you'll also see that we're symbolizing the entire data set at the standard legend level. You saw Jules' slides. He had it symbolized at the subcrop level. So we've chosen to just go with these categories because it's enough for the eye to just handle this many colors. Okay, so what can you do with the app? First, this app primarily is for people to get at the data. So you can just go ahead and download the entire data set as a file geodatabase or a shapefile. You could also do this by hitting the REST endpoint of the service, but you would need some code to process those requests. So we've just packaged it and put it as an easy download link. That's for the whole state. You can also turn on the county land use or the Bulletin 118 groundwater basin. So these are the county land use, county boundaries. If I click a county, let's see, I'm going to click Placer here. Or no, it's Nevada. Oops. So Nevada County has 2 surveys. We have the statewide remote sensing 2014 pre-clipped to the county boundary. So you could download that just for the county. Or you could get our DWR survey for 2005. Let me find another county with a provisional survey. I think Mendocino. Yeah, so we have also made available provisional county land use survey data sets. And the reason Mendocino has 2 is because it's split by our region offices. So we have a provisional survey from one region office, followed by one that has been brought up to the highest standard, has been fully vetted and released on the land use website. But we've made the provisional data sets available because we want to get as much data out there as possible for GSAs to use in their groundwater sustainability planning. Okay, so you can also click groundwater basins. Keep clicking the middle button here. Okay. So, and as far as groundwater basin downloads, you're just getting 2014 data. We haven't compiled different land use data sets, land use survey data sets into basin boundaries because they don't match the basin boundaries, and we would have to make determinations about, okay, well, are we going to include 2006 to 2008? So we haven't made that determination. You would need to download each county survey and intersect it with your basin as a separate GIS process. Okay, so that's downloading the data. Now let's look at filtering the data in the viewer. So when you click the filter, this is a dynamic filter. It brings you into a zoom level that is going to help your performance because now when I filter out crop mapping 2014 truck crops, and before that I'm actually going to go to this base map gallery and turn on a dark gray canvas so that we can get better contrast. So what you're returning now in the viewer is the actual polygon vector data, and we're not in the tile cache anymore, and that's why it's a little more, the performance goes down slightly if you're too far away. So you can go out one more level, so slowly you see it's popping up. There we go. That's all truck crops, the standard legend for this part of the Central Valley. And so you can turn on other, there comes the field crops, here comes the citrus. There's a lot of citrus down here in the foothills of Fresno. And then, so maybe we'll back up. Let's turn on the idle. So this is 2014 idle. Oops. From the 2014 crop mapping data set. Now let's turn on idle from the county surveys. So when you first turn on idle from the county surveys, you're actually viewing idle fields from every county land use survey done in this area from 1986 till now. But you don't want to see that. You want to see specific years. So if you turn on the time slider, now you can filter that county survey idle crop in this time window. So let's say we have a Fresno County survey from 1986. So now that we have our time slider, so now the tools start adding up. It gets a little more complicated. You have to get used to using the app. You've filtered down to idle from 1986 to 1989 for the Fresno County survey. We don't have survey from the south, from Madera or is that Kings below Fresno? Tulare. And now what you can do is switch over to the slider tool, choose one of the layers you have in your viewer. So I'm going to choose Statewide Mapping 14 to swipe on and off the app. I'm still filtered down to that time period. So you can see, just visually, the amount of acreage that has been idled in 2014 because of the drought. Now, let's say you wanted to quantify that. So the final tool I'll show you is the spatial query. And I'm going to turn off. So this is the dynamic filter. This is really just to visually make these quick. You have a quick question you want to answer. You come into the app. You filter down to a crop, specify a time period. You can get just a visual confirmation. But maybe you want a number. Maybe you want to know what was the actual change. Whatever results you get out of this app, they're completely provisional. This is not an app for, production analysis. You should do proper GIS analysis in your desktop with correct projections to get good data. This is more of just a provisional answering your questions that just come to mind in conversation. Maybe you're in a meeting and you want to confirm something. So let's quantify the actual idle change in this area here. So what I'm going to do is I'm going to turn on the basins. So we see San Joaquin Valley west side. I'm going to start with Ag Statewide Crop Mapping 2014. I'm going to choose idle. I can just start at the standard legend. I don't need to go to subcropping. You could also filter down to, well, this is being filtered by the top. I'll just show you. You can actually filter down to any of the subcrops. But I'm going to do idle. And I want it to be an intersect with the Bulletin 118 groundwater basins. Let's select the basin and execute. I'm going to call this idle 2014 west side. Let's let that run. All right. So it pops up here in your operational layers. You have all the idle identified polygons in west side. So that was a spatial query. You'll notice that the intersects aren't true intersects. They are, let's see if I can find one. Yeah, here's one. See how the basin line actually is coming through that field? In a GIS desktop software, if you did an intersect, it would cut that field in half and say, okay, this is the part of the field that's actually in the basin. In the web app, that geoprocess is not truly made. It's basically just everything inside and anything that touches that boundary. So if you have an urban layer, and the urban polygons are quite large, if it touches that basin line, you're going to get the whole thing. So you got to be careful. So okay, we have 1,743 idle fields. We just want to get some statistics. So acres. Okay, sum of values, 224,446 acres of idle fields in 2014. Now let's go back to our query, and we're going to hit the Ag County Land Use Surveys. And we're going to specify the timeline, 1980, whoops, 80, whoops. Okay. I'll just point out to you again, you can filter those county land use surveys down to the subclass. You can even specify if you want multi-use. You can even specify the water source. All those are just the high-level attributes identified in a DWR county land use survey, which are not available in a remotely sent survey. But we allow you to query those in that spatial query tool. Again, we're going to choose intersect with, got to scroll all the way down, basins. Select west side one more time. Hit execute. Call this idle DWR survey. think it was 1988. Okay. Only a few fields. We have 30 fields. We have 2,300 acres. So quite a difference. You can also export these results to a CSV file. One thing you're not able to do, let's say I queried out, I didn't specify which crop. I want all the land use surveyed in that boundary. You won't get a graph, a bar graph kind of dissecting each of those crops. That would be something we'd have to add on later. But what you can do is once that query result appears with all the crops, export that result to a CSV file and pop it into Excel. You can do some quick subsequent analysis based on those results. So that's the extent of the spatial query. I'll just point out a few more things. You can add data. So here we have some suggested layers that we make available. So you could add those to the map, water districts, the DAUs, CDFW, owned and operated lands. Add those to the map, use those as part of your spatial query. That's available. You can also switch this to AGOL, search almost any available public layer on AGOL. You can also use a URL endpoint. And that URL endpoint can be a KML file, a GORSS, so that's like a live feed, or a CSV file with Latin longs. But for example, CDFA, they host NAPE 4-band imagery, and so you could grab the infrared image. I think they call it, there's a special name for it, but it really shows you what is healthy vegetation versus a field that's fallow. You could bring that in and do some visual confirmation for yourself. So you just pop in the URL endpoint for that REST service, or you can upload your own file. So let's say you have an administrative boundary, project boundary, anything like that. Just upload it as a shapefile or a GeoJSON, the open source JavaScript open notation file. Those are really nice to use. They're not tied to any certain software, so you can browse, upload those in, and use those as part of your spatial query. And finally, you can print. So let's see, this will pop up. Yeah, it'll give you a nice little viewer layout. You know what's in the print window. You can change your scale. You can change the layout and the format, and change the DPI. I have it at 300 because you want it to be decent quality. It might take a little longer, but it'll be usable, in a meeting or whatever you're trying to do, as just a quick reference. So that's the extent of the app, and I want to leave time for questions. I know we started a little late, but maybe we can go over 5 or 10, 15 minutes. So we made this app go live last Friday, and so far we've had about 1,000 visitors, 50 downloads. So definitely the app is useful for folks. We're going to do another webinar release this Friday with another presentation, some more detailed discussion about how this land use can be incorporated into GSP planning.
This is great. Thanks. Thanks all three of you for being here. I think we're going to do some question answer. Maybe just introduce yourself and say who your question is for, or you can direct it to all three of them, and we'll go to anything online after we do in the room.
Hi, I'm Bree Lindsay from the California Council on Science and Technology, and my question is for Joel. You were talking about the inaccuracies being sort of biased towards smaller polygons, and also that the crops that were misassigned were assigned crops that had similar features. But I was wondering, do you have any biases in the types of crops that are misassigned? Like, is it more likely that you're going to always have your inaccuracies only in almonds? Okay.
Thank you. I forgot to mention that, yeah, you have to speak in the microphone.
Yeah, no problem. So there was a table in my presentation that by crop had the accuracy, and so as I mentioned, we're generally more accurate for higher acreage crops is the general trend in most cases, yeah.
I'm just asking if there are specific crop features that would lead to a misclassification. So I know that certain types of crops are grown in larger acreages in general, but if you were to compare in the same crop size, if there would be certain types of crops that would be more frequently inaccurate.
Not to my knowledge, no.
Other questions in the room?
Thank you. Elizabeth? Oh,
One second. I just wanted to point out that the app has a lot of information available about the data set, the background, the methods, and the data collection. And those are the high-level summaries, but you can also download the full statewide crop mapping report, which details probably a lot of the questions that might be on your mind about the data set.
I'm Elizabeth Betancourt with the Sierra Nevada Conservancy, and I was just wondering, I don't think I heard much about exactly how this is used, so I imagine it's used to calculate how much water was used in historic years for irrigated agriculture, but is it possible that it could be used to project water use as well? And if so, does that have any implications for management strategies or bookends or anything like that?
Yes, I think very much so. So how DWR uses this, so we identify, we get what the crops are, and then what we do is we read it into a program called Calcimita, which I can't remember what that stands for, but basically that takes the crop in that certain location, climate, precipitation, all that stuff, and it calculates what the applied water is for that crop. And so that's how DWR is using it. And yeah, to answer your question, yeah, we could use it for forecasting future scenarios, you know, projecting 50 years in the future or something like that is all, you know, we're hoping people use this information for.
So as we finish the 2016 mapping, and you can integrate some of the past DWR crop land use mapping, you can begin to establish trends, right, which will help you with your forecasting question, I believe. So there's more than one set of data in a given spatial area that you can establish those trends.
Other questions?
So it's a crop coefficient approach. So we have a reference ET, we have a reference consumptive use, and we have a factor. And that factor is determined by the crop type. And so if you know the crop type and you have your factor, that's your crop water use based on, you know, climatological measurements with a factor. And that factor is all is for that specific crop.
I heard your explanation. Sorry, Dan Constable, Delta Stewardship Council. I heard your explanation that this is focused on irrigated, on wetted area, not on rangeland or natural vegetation, but I was wondering if there's been discussions in the future looking at non-ag land, so either rangeland or otherwise natural use that also has consumptive use in areas as well.
Yeah, we look at those land use categories a little bit, not for this purpose, because we did this for Department of Water Resources, of course, so it centers on consumptive use. There are other publicly available spatial data layers that are out there that you can overlay with these data layers, that you can clip to and correct the topology errors that will occur when you overlay one on another, and probably get at native layers from other publicly available data sources.
and I can't speak for the Department of Water Resources, but speaking for the Department of Water Resources, we would love to partner with other agencies, and I mean, there's a lot of interaction or intersection of data needs when, you know, if California Department of Food and Ag, Department of Conservation, Delta Stewardship, like, we should all get together as agencies and determine what we need and do this once rather than each of our individual agencies doing individual efforts like this. So just
That answer your question?
Does the land use survey include privately owned commercial forest land and livestock, managed livestock feedlots and poultry farms and things like that?
No, it currently does not.
We'll show you, though, one of those add data layers. Let's go back to the curated list here. Department of Conservation's California Important Farmland. And they do this, I think, every year, every 2 years. And I think it's these brown ones. Let's see. I think we'll have to go back to here. Anyhow, I think I can turn the pop-up on. Well, oh yeah, if I just down the legend. Confined animal agriculture. There are these brown, I'll just turn that up. Those are feedlots. And so you can sort of, you know, use 2 data sets to help you out. You know, it's an ensemble application.
Hi, this is Salma Kibriya, DWR. When you were showing the query for each like single year, did you add multiple year data in the same GIS layer, or you had to join separate layer for different year?
Microphone. What?
Hard to remember.
So I took all the surveys that DWR has done, and I combined them into one GIS feature class. And we published that to HOL service for now. It's not an Atlas data set. It's provisional just for the app purposes. When you download a shapefile from the county, you're getting the actual survey. You're not taking it from that combined feature class. The combined feature class was just published so that we could enable time on it. And so we weren't filtering multiple feature classes in the app. We're just looking at one. But that's just for the app. When you download a county survey from this application, you're actually downloading that individual survey that has no further geoprocessing. There's been no geoprocessing done on that, so you're getting the raw production data. Does that make sense?
I have a question. How come you didn't also add DAU boundaries?
Well, okay. Let's. Part of it is, I think we all look through a certain lens, and if we were to try to add every administrative boundary or analysis, and I know a lot of folks probably use DAUs, but the more and more layers you add onto this layer list, the more and more difficult it is for folks to just get at the data, understand what's happening. If I added DAUs, somebody else may say, can you add HUCs? And what HUC? HUC 8, HUC 12, HUC 16, is there a 16? So, you know, we just went with the county and the basin. Start there. You can get at those other URL endpoints for DAUs. If somebody, I know there's HUCs already published, just add those into the app, do a spatial query, and if you really need that data processed by DAU or HUC, you should do that in a desktop software.
Thank you. Other questions?
Are groundwater recharge sites included in the survey? The locations of, or?
No, we are doing separate efforts, and I know Land IQ's done some of that with the Almond Board, I believe, but it's not part of this application currently.
There's questions for Joel, and if it's in the report, feel free to just refer me there. These look like really, I mean, they're vectors. They're very nice and clean lines, but you developed it from raster data originally. Was this all downsampled to NAPE resolution and then rebrought back to a vector? And my question why I'm asking that is if there's a way you can look at the distribution, the frequency of different field sizes and map that back to crops. So I can say an almond crop on average is 276.3 acres versus this other crop type, or what is kind of minimum mapping unit on those edges?
Yeah, so first off, I remember I told you we have these two disciplines in my company, land-based scientists and spatial scientists. I'm the first one, not the second one, so I can answer your question only roughly. The minimum field size, again, is 2 acres, and all this stuff, all the information you're requesting is actually in the report, and I don't know why you can talk about vector and raster and how we deliver it to you.
Well, this is all, when you download the data, it's all vector. So they draw a field boundary, and then they use it to determine what's in that field, and then that whole polygon becomes almonds or walnuts or something like that. So you could do that if you download the data, you know, do it by individual polygon and get those statistics. But it's not a raster data set. It's a vector data set. The GIS, the original GIS data we got from Land IQ is vector based.
I want to ask, are there any questions online? Folks online are quiet. Quiet folks online. Does anyone else have any questions? We have just enough time for one, if there is one. Paul.
This question is for Joel. This is Paul Shipman with DWR. Could you talk just really briefly about how you're going to do multi-cropping? We said you're going to approach it in 2017-18.
Yeah, I suspected from your presentation you might ask that question when I came in. So it's the same process as doing a one-time shot, as you see in 2014, but doing it 3 or 4 times during the year. And being aware of the phenological growth cycles and what crops are predominantly grown where, and planning that ground truthing effort to hit those types of more dominant crop cycles. Part of our analysis is a temporal analysis. We look at multiple images over time, and so the end result is intended to be a field by field. How many times did that field get planted during the last year, and what was it? And so that would be the result.
One follow-up question.
One really quick follow-up question. Sorry. Spinach in particular is extremely difficult because it has a very, very short cycle. Have you guys thought about that at all? I'm just curious. Do you know what you're going to do with spinach?
You're correct, and we talked about that earlier in a meeting with DWR today. Same concept applies, and so it's just going to be about the frequency of visiting or the frequency of the image that we get. So, and don't forget, just because we create a fingerprint or a signature of what spinach looks like, we don't necessarily have to be there at that time. We have to have an image at that time to match that fingerprint up with the image in a kind of a layperson's way of describing it. Yeah. Hmm?
I'll just say, you know, DWR going from the county surveys, that's one area we're looking at is what, you know, we have all these land use scientists that can now go and concentrate on those triple-double cropping areas as opposed to having to do a whole county in a year. So like Joel said, we just had a 2-day meeting on how we're going to transition more and more towards this remote sensing. So more to come.
Thank you. Let's give them a hand.